I just want to very quickly introduce Geospatial Council of Australia. Sorry, I've gone one too far. So one of the many things we do is policy and advocacy, and the bulk of our activities in that area is around workforce, trying to work with various agencies and entities to address the workforce shortage. Economic benefits of geospatial, we've got a big emphasis on that at the moment, and industry recognition, because it's still, the geospatial sector is still very poorly understood in the wider community. One of the things that we're doing at the moment, that we're about 40% through, is that we've engaged ASL Allen in conjunction with a number of both government and industry partners that have contributed to the funding of this study. And we're undertaking an exercise to determine the value of geospatial information to the Australian economy. And we're looking at not just economic benefits, but the primary focus is economic, because to really get the interest of governments and influence policy, it's very important to show an economic benefit. And digital twins, of course, are a very important component of geospatial. And we are doing a sector by sector analysis across all the different sectors of the economy. And there's some very interesting findings already, in that between 85 and 90% of the sectors in the economy are using geospatial in some part of their mission critical operations. However, the uptake is really low. When you average it across the whole Australian economy, the uptake is under 10%. And so I guess the good part about that is that there's a lot of opportunities for growth and improved benefits to a whole heap of different industries. So this study is incorporating all the elements of geospatial: earth observation, positioning, navigation and timing, surveying, construction, defence, agriculture, environmental management, emergency management and response. So pretty much we've identified 20 main sectors plus another 40 subsectors. And the reason I introduced this economic study, because, well, one is it's very relevant, but two is I've tried to collect some data, global data, on the size of the digital twins market. And it's a bit scarce. I don't know if anyone else has tried this exercise, but in this report, which was released in the third quarter of 2023 by BIS Research, the global market in 2020 of digital twins was only at 2.7 billion. So even though we've had various forms of 3D data sets for 20 to 30 years, digital twins were still a very early concept in 2020. Now, the prediction in this report is that by 2025, it will be just under 30 billion. And then if I went to another study, the Gartner report, and they're predicting that by 2027, it'll be 73.5 billion, with a compound average growth rate of 60+%. So it's pretty dramatic growth, and a very exciting emerging field. They reckon that 40% of large companies worldwide will use digital twins in their projects to increase revenue or increase efficiency, that should say, I think. And 89% of all IoT platforms will contain some form of digital twinning by 2025. Now, the downside is that we tend to collect a lot more data than we actually use. So a lot of the data that I just showed you was really based around the construction sector. it's quite difficult to collect economic digital twin data outside of architecture, engineering, and construction. And so this estimate of 95% going unused, and then of the data that is used, on average, it's used less than twice. So between 1 and 2 times. So a lot of the data just sits in the cupboard. And it is hoped that digital twins will ensure that more of this valuable data gets used, but it's an alarming statistic, I think. Now, this is very focused at building infrastructure, this diagram, and what it's actually showing is that during construction, there are substantial improvement opportunities from the use of digital twins. And then once it moves into operations and management, so this is showing the total cost of ownership over the life of the asset. If you don't have smart asset management tools, then the cost of managing that asset goes up quite dramatically. So with the use of digital twins, you can get up to 40% total cost savings over the life of the asset. So it makes it easier to justify the costs of doing digital twins. And in line with the government and versus private role, I just want to show that in spite of all the expenditure, in spite of all the growth, as of 2023, now I'm not sure what their KPIs are to determine a fail, but the claim here is that 70% of digital transformation efforts fail. Now, it may mean that just not all of the outcomes and aims were achieved. Some may have been, but there's a whole heap of reasons as to why they wouldn't fail. And looking at some of the earlier presentations, particularly the one from Darren, with the process they've been through to get Spatial WA to the point that it's at now, it's that process of establishing a business case, define deliverables, which involves a lot of consultation, define KPIs, which involves further consultation. And my understanding is that pretty much every government agency has been consulted in the process of Spatial WA, and there has been a number of industry sessions as well. But there can never be enough consultation to really get the optimal outcome. Within the uses of digital twins, obviously 3D BIM, AEC data, current operations and maintenance, and BAS and IoT. And again, federated platforms that have been discussed earlier, they're the aim, but it's easier said than done to actually get there. All of the numerous use cases, there's far more than what's displayed on here, but it never ceases to amaze me, particularly with the maritime digital twins, where some of the port management systems, where they're more of a dynamic digital twin, they're monitoring the arrival and departure of ships and what cranes are operating, what are out of service, the number of sea containers moved in a day. There's just an inordinate number of uses. The maturity level is something that has been spoken about a lot. And if you look at where we are on this diagram, I'd say we've got a way to go. I'd say we're still really predominantly in the informative twin. We are seeing predictive twins and some more comprehensive ones, but they're not widely in operation. Many of them are research projects, but there's certainly, by the time we get to autonomous twins with alarms and just telling us everything we need to know without having to inquire, we've got a way to go. Within Australia, there's been a lot of investment at the state government level into digital twins, and I think it's actually appropriate because, as it's already been pointed out, the private sector will be driven by profit and looking for efficiency gains, whereas the government has a role to actually provide a framework that the private sector can then add to. Now, in New South Wales and Victoria, they each developed digital twins with a approximately 40 million allocation, and over various durations. One of the issues, I think, even though particularly in New South Wales and Victoria for that matter, there's been case studies showing a fabulous return on investment of having access to digital twin. There's still a big question mark hanging over whether these will be continued to be funded. And if the funding dries up, then of course you've got a maintenance issue of keeping the data current. In WA, they've taken a slightly longer term approach. This is public knowledge, where it's 140 million over 10 years. But all of these, WA, New South Wales and Victoria that I'm talking about, they are really a supplier-driven approach. So the agency primarily responsible for geospatial data is driving these twins. And Queensland, on the other hand, they've been a little bit quiet on their digital twin. They've developed a substantial business case, but they're suggesting that the digital twin responsibility should sit instead with the Department of Infrastructure, so that it's a user-driven approach and more likely to receive ongoing funding when it's linked to all of the infrastructure that the Queensland government funds. And they have been active on a smaller scale with digital twins. So they've got the Cross River Rail project, which is a $7 billion rail and a whole lot of new stations involving substantial tunnelling. And there's a digital twin over that entire project. And the business case was to take the same standards that they've used in that Cross River Rail project to a southeast Queensland digital twin. Now that's still pending, but given Brisbane's got the 2032 Olympics, I think there's a strong opportunity that Brisbane or Queensland will get funding for a massive digital twin. ANZLIC's played a role. So for those of you not familiar with ANZLIC, it's the Australia-New Zealand Land Information Council, and it's a consortium of the state and federal governments of Australia and New Zealand and all the state governments within Australia with geospatial responsibilities, and initially came together for data sharing arrangements between states and Commonwealth, but it's developed much further than that. And it's a very interesting model where the states and territories regularly meet, collaborate, and they've actually developed a framework for spatially enabled digital twins. And that's what this is that we're looking at. And so from the ANZLIC perspective, digital twins principles must deliver public good. You could argue that they must also deliver commercial outcomes as well. They should provide ongoing value and location-based insights. They should conform to agreed standards of quality, be adaptable, and be open, and as open as possible. And then having those function and form elements is potentially a little bit in conflict with the governance and accountability, security and privacy, curation, standards, federated model. So the future of digital twins is standardisation. It is absolutely fundamental, particularly if we want to have living, growing digital twins. So we need standards of protocol, standards of the digital twin itself, even standards of data collection to make processing easier to feed into the digital twin, and collaborative working. I'm missing a diagram here. Here we are. Sorry. So shared learnings, data, digital twins are a way to unlock data from silos, but at this point, the silos very much exist. Investment in data is still needed, and standards are needed as a priority. Governance and federation models are still in development, and I think there's a lot more discussion to be had on solving the governance issue because they are such big data sets. And a lot of time is being spent on technology selection and architecture, but it's going to be important for the technology providers to also be prepared to collaborate on providing agreed data standards rather than their proprietary formats. And research projects in this area are extremely important, and they will quickly build on government digital twin initiatives. The value of a digital twin across multiple domains is obvious. It impacts multiple professional disciplines. It's not just for cities. It can be used for the natural environment. It can be used over broad regional areas, and the expectations are growing. There's even a proposal to get a global digital twin underway within the EU. And multidisciplinary teams are really the only way that this can happen. I just want to make the point that in the engineering world, data for projects is collected and has been collected in 3D for decades. And until fairly recently, that was basically dumbed down and presented in two-dimensional views. But what we're seeing now is that in the pursuit of efficiency gains and increased profits, the private sector on infrastructure working on infrastructure projects have absolutely embraced the 3D environment. And so the data is collected in 3D, it's delivered in 3D, and it's shared across various platforms and applications and used in 3D. So instead of printing a plan with cross sections and long sections, the user can place a section anywhere they want. So if they're doing a rail line and they want to see the camber on a curve, they can just put the cursor on the screen and extract a section. For structural analysis, LiDAR is particularly useful for assessing if a building has been constructed to within tolerance. And those red areas are indicating components that are not within tolerance. And it's a really useful tool. So if you were looking at, say, a steel structure, the tolerance of the columns would be far more vital than, say, the struts. There's a bit more room to move, but it's incredibly useful visual tool. I just want to finish on this. So this is a Perth project, Perth Metronet project. It's 72 kilometres of new passenger rail and 23 new stations. So it's a massive expansion of the existing Perth rail network to really lift the public transport in Perth, which has been lagging, I think, compared to some of the other Australian cities. It aims to improve 8,000 hectares of residential land into desirable places to live, work and play. The Public Transport Authority, who are, I guess, are the lead agency for this project, and the contractors don't yet have an aligned geospatial digital engineering strategy. They're aligned in many ways, but the contractors actually have great difficulty in sharing data and progress reports with the PTA because the PTA are not yet working in a true 3D viewing environment. The project spans multiple local government areas, and as you cross local government boundaries, there's also inconsistencies at that level, and all of these things impact on the actual rolling out of the rail and the stations. All disciplines depend on this 3D data, and I think Spatial WA provides, hopefully, a way forward to ensure this data forms part of a living, growing digital twin, and perhaps with mandated data sharing as a minimum for government-funded infrastructure, we could see digital twins become far more commonplace and delivering even better returns than they are now. So that's all from me, and happy to take questions if there are any.
Great, thanks, Tony. If people want to put their hand up, if they've got a question, but I do see one already in the chat from you, Arthur.
Yeah, this is a tricky one, Tony. So in the old days, before we had App Store, it was a bit of a chaos of bits and pieces of applications spread all over the place. So what if, and this is a bit of a wild idea, what if there was a digital twin store similar to the idea of an app store? So I could go there and I could get a collection of data from, or reference to data from SAM, for example. So that gives me my underground picture. Or I can plug in somebody else's active agent and plug it into my data set, or I can drag a model from someplace else and drop it in. This is sort of fitting the theme of standards, but just sort of struck me that that's one of the things that has unified applications in recent history. Just some thoughts on that, Tony?
So you're suggesting a register. So rather than have a ginormous digital twin where it's all there, have a register where you just go, you go to the party.
Exactly. So my digital twin right now is helping me, my example of agriculture, it's helping me with agriculture, but okay, I want to plug that into the supply chain now. So I would go to my register and grab that chunk and add it to my digital twin, and it just fits in.
Yeah. I think that idea's got a lot of merit, given it's far more achievable in the short term than a digital twin over the whole of a state, for instance.
Yeah, that's what I was thinking.
Mm.
Great, so we will have one more question. Marcus, go ahead.
Yeah, this is more a comment to this Arthur's statement of the App Store. In the way we look at digital twins, in the world avatar view, where you have ontologies and represent knowledge rather than just data, then and where you use the internet that's completely decentralized, then the question basically boils down to federated access, federated querying. Okay, and that is a big thing. And in fact, I don't think we are that far away, because we can already query across Germany, UK, and Singapore. So it's possible that, but there are speed concerns. Okay, how far can you get access levels and so on. And because the individual, what we call semantic agents, they could be viewed as local digital twins because they are semantically represented. The whole, you can find them through just the Google search type of activity. So this register in a sense already exists. So the key point is, how do you do federation? How do you obtain speed? How do you deal with the overall demand? But Google has already solved this. Okay, so you will need large computing facilities, that's for certain, and to obtain the speed and the volume. And And you need to have some more clever technology that at the moment exists to do the federation. That's a general comment. Okay, thank you.
And that sort of boils down to standards as well, Marcus, right? Because you can't have people playing several different games in the same space. That's not going to work.
I'm actually I'm not bothered about standards, to be honest, because the moment you have a knowledge model, you can have agents that sort it all out. Okay, I mean, like, it's more important to go ahead, put it in, develop your ontology, and then let the cleanup happen automatically. That's why, I mean, of course, it's good to have standards because it helps you to formulate the ontology. But in my view, you know, the moment you do standards, the more you do it, the more it sort of gets out of whack. Because
Yeah, so let me qualify that just a little bit, Marcus. I think
yeah.
what I'm driving towards is in the idea of the standards is, for example, ontologies must be modular, right? That would be a rule that you would adhere to, right?
Yeah, I mean, we would like to, but to be honest, the whole ontology field, in my view, this is still a little bit of a mess. And there will be some sort of consolidation. I don't think just a human effort is able to do this, because there are so many. I think the community, humans plus algorithms, will over the next 5 to 10 years sort this problem out. And also the question of large language models. We haven't discussed this at all here. In my view, in terms of standardization, they may play an important role. Because if you know, the Googles and the OpenAIs of the world start extracting ontologies out of language models, then we will find very quickly that the human-made existing models very quickly will be either obsolete or outdated. One shouldn't look at the ontology as something static, right? This is a bit like our human view of stuff changes all the time. The notions we use to describe things is changing all the time. So this is another reason why I'm not so worried about the ontologies and standardization. I mean, like, of course, creating knowledge models are important, but what type of standards you use, to be honest, I don't care.
Yeah, great. Thank you, Marcus, Arthur, Tony. It's such an interesting discussion, and I'm sure that we could discuss this topic for another 6 hours. It's a fascinating area, and I think there's lots of work going on right around the globe. And we've just looking at helping a PhD student on that topic at the moment. So really great conversation. I will wrap the session up now. I'd like to thank everybody who presented today, and people that asked questions and came along. Much appreciated. I do want to shout out to Arthur. Arthur's been a driving force of getting this together, so thank you very much. And also amazing to find time to do it in this very busy time of your career when you're just about to retire. So thank you so much. Really, really appreciate it. And to Jeanette, Melind, Mark Enza, Isan, and Tony and Chris Healing, just wanted to really say thank you to everyone that's been on board organising this. To the sponsors, we'll send out a feedback link, as well as sharing the presentations from this session and the other sessions. And hopefully, if we get the right type of feedback, we will be doing this again sometime, because really it's inspirational to see what other people are doing. It's a great opportunity for learning, and it's good to connect with people right across the globe. So thank you very much.